Remarkable structures like the Burj Khalifa, the Golden Gate Bridge, and the Sydney Opera House display the final product that a team of structural engineers have spent months and if not years designing and assisting with the construction process. Although how these engineers get to a level of experience where they're able to piece together these complex projects is through years and years of design tasks which they started doing as a graduate. So in this video, I'm going to share with you some of the design tasks I do as a graduate structural engineer in my first year out of university. At uni, when you're studying civil engineering, you learn so many different design concepts and theories that it's really hard to know which ones you should remember and which ones you're actually going to use after you graduate. And hopefully by the end of this video, you'll be able to pick out those more practical things that you ought to pay special attention to in class and study in more detail. And if I can give you a quick tip before we start, keep practicing these things even after you finish the course you learned them in. You'll definitely need to know how to do these things when you start working as a graduate engineer, and it'll be a lot easier if you don't have to relearn them and you just kept up the skill while you're at university. Alright, so the first design task I want to talk about is load takedowns. A load takedown is basically the process of working out all the loads that will act on the individual element you're trying to design. Typically, there are 4 different types of loads you'll design for. They are dead load, live load, wind load, and earthquake load. And depending on where you're designing for in the world, there can be a 5th one too, which is snow load. However, the main 2 loads which are applied to essentially any element you'll design are dead and live load. For example, say you've been tasked with designing a floor beam in a small office building, so you only need to consider dead and live loading. When working out the dead load, you need to consider the self-weight of the beam and also the superimposed dead load which falls within that beam's tributary area. In case you don't know what superimposed dead load is, it's basically any of the extra material which will form part of the permanent structure, like floor finishes, tiling, plumbing, and electrical cabling. And tributary area is basically the loaded area around an element which contributes to the total load on it. And for live load, since we know that this beam is going to be used within an office area, we can take an appropriate area load from the design code. In Australia, this is AS 1170.1. Okay, so the second design task you do a lot of is wind design calculations. Wind design calculations are a lot more complex than dead or live load calculations because they depend on a lot more factors. A few of the factors they depend on are design life, importance level, height of the structure, and also its location. These calculations typically also involve working out internal and external pressure combinations so that you can see the worst effect on the structure. At this step, you also usually take the time to work out all the load case combinations that also involve dead and live loading and any earthquake loading as well. Okay, so the next task is building structural analysis models. 2 of the programs I've found myself using a lot at the moment is SpaceGas and Strand 7. Often what I'm doing when I'm creating models in SpaceGas is inputting the loads I've worked out through hand calculations and using the results to design steel members that form part of a shed or warehouse. What the process of building one of these models from the start looks like is firstly reading off the architectural drawings to get the dimensions and overall layout, then inputting the support types and any of the member end fixities. From there, you assign a material and a first guess size and section type for each member. Next, you input all the loads you've worked out by hand and create all the load case combinations so you can see the appropriate loads acting together. Once you've done all this, all you've got left to do is run the model and analyze the results. Now that you've got a basic functional model, it's really easy to jump back in and change any of the member sizes or sections to make your design more safe or economical as you need. Alrighty, so the next design task is member sizing for steel structures. What you're doing in this task is basically using the results from either a model you've built or from a hand calculation you've done to pick a member size that will work given your design loads. And basically there's 2 criteria, serviceability and strength, and you'll use both of these to determine which member size is appropriate. For serviceability, there's suggested deflection limits in the code depending on which element you're trying to design. In general, for a beam you could use span on 250, and for a column you could use height on 500. For strength, there are a lot more checks you need to do, but essentially here you're just checking that the section capacity is greater than the design action. A few of the design actions you could be checking here are bending moment, shear force, axial tension or compression, or any of these in combination as well. Usually this process involves a little bit of hand calculations and also going to your design capacity table books and reading off the specific values you need for your scenario. Alright, so the next task is design markups. Design markups are a big part of structural engineering as they form the first draft of what drafters use to create construction drawings, what estimators use to price work, and ultimately what builders use to create projects. Essentially, what you're doing in this task is sketching and annotating the design you found work, either on top of architectural drawings or just onto a blank piece of paper. Usually these markups are drawn using a PDF editor like Bluebeam, and just consist of 2D drawings that are made up of lines, shapes, text boxes, and shading. While this may seem like one of the more easy design tasks you have to do, it actually does require a high level of attention to detail because it's not always so straightforward how you should display things. What I mean by this is that sometimes you really need to think about the symbols that you're using, the scale, and also that you're only showing the elements that you can definitely see from the angle that you're drawing from. Okay, so the last task I've got for you is shop drawing reviews. Shop drawings are drawings that have been produced by the manufacturer and are the drawings that are going to be used to fabricate the final product. Usually what happens here is that us as the structural engineers will send off a basic set of drawings of what the structure will look like, alongside a few of the basic details of how we want things to be connected, and the manufacturer will use this information to create shop drawings. Once we receive these shop drawings back from the manufacturer, it's our job to check back through them and make sure that they've interpreted our drawings correctly. A few of the things we would be checking for steel shop drawings are correct section sizes, connection hole size and spacing, and plate thicknesses. Alright, so there you have it. There's some of the design tasks I do as a graduate structural engineer in my first year out of university. I really hope you found some value in this video and picked up on a few of those design tasks that you should continue to practice throughout your time at uni. Also, if you're interested in learning about the full note-taking process I used while at university, you should check out this video I made here. And if you want to know the study tips I wish I knew before I started university, check out this video I made here. Okay, that's it guys. Thank you so much for watching and I'll see you in the next video. Bye bye.